students, a very warm welcome to Ritu Maths classes. Today we have taken up the topic of properties of determinants. Determinants is a chapter from class 12th. So we will be going through the properties. Let's start with today's video. Very first property says determinant of A is equal to determinant of A transpose, where A is a square matrix. That is, if you have taken a square matrix and you expand it through any row or any column, you get the determinant of A. On the other side, you could have taken the transpose of the determinant of the matrix. First of all, how? You could have interchanged the rows and columns and then do the expansion to solve for its determinant. The determinant's value will come out to be the same. So that is the first property. Second property, if any two rows or columns of a determinant are interchanged, just row interchanged with row, that is if you are going for Ri interchanged with Rj, or you are going for Ci interchanged with Cj, then the determinant sign changes. For example, you have to interchange R1 with R3, or you have to interchange R1 with R2, any two rows, or similarly any two columns you interchange, and then you solve for the determinant. It will come out to be the negative of the original determinant. So if the original determinant has having positive symbol, the resulting will be negative, and if the original determinant was negative, the resulting will be positive. So it is in this case when you interchange any two rows or any two columns. Next comes the third property. If any two rows or columns of a determinant are identical, when we say identical, it means to say the corresponding elements of any particular row are the same with another row, or the corresponding elements of any column are same with the another column, then the value of determinant becomes 0. In simple language, we say determinant vanishes. The whole determinant will come out to be 0. Next is the property number 4. If each element of a row or a column, a particular row or a particular column of a determinant is multiplied by a constant k, then its value gets multiplied by k. For example, you have multiplied just one row, first row or second row, maybe any of the rows, just one row with any constant 5, then the whole value of the determinant will be multiplied by 5. So if it's in case of that you are multiplying first row by 5 and second row also by 5, then the whole determinant will be multiplied by 5 into 5, that is 25. So in the other words, we can say that we can take a common factor out from any row or from any column. Next is fifth property. If some or all elements of a row or a column of a determinant are expressed as a sum of two or more terms, then the determinant can be expressed as a sum of two or more determinants. For example, you are having the first row of the determinant like a plus lambda 1, then next entry is b plus lambda 2, and the third entry in the first row is c plus lambda 1. Second row, third row are simple. They are having simple elements. Since first row is expressed as a sum of two elements, so you can express the whole matrix as the sum of two matrices, the two determinants, because the whole first row will be split in the first determinant, and it will be having the entries a, b, c, and in the second determinant it will be having the entries delta 1, delta 2 and delta 3. Let's come to property 6. The value of the determinant remains same if Ri such that Ri plus k times Rj, or Ci such that Ci plus k times Cj. These operations you have already done in the chapter 3 matrices when we say elementary transformations. It means to say that if I select any row and I add the equimultiples of any other row into this, or I select any column and I add the equimultiples of any other column into this, the determinant will remain to be the same. And here it is one more important factor, that when we use these elementary transformations in the case of matrices, we use either the row transformations or the column transformations throughout the same question. If I have taken the format A is equal to IA, I will be going for row transformations only. If I had picked up A is equal to AI, this format, I can go for only column operations. But here it is quite relaxed. In the same question, I can use in one step, supposingly I'm using the row operations, and in the next step I can use the column operations. So it is quite relaxed in case of determinant, and the determinant will remain to be the same. This is the most widely used property of determinants, the last one, sixth one. And in board exams, we generally get a question from these properties, especially sixth is used. It is written in the question without expanding, or it is written using properties of determinants. Without expanding or using of determinant means, using the properties means we have to use the properties first and then expand. We cannot do the expansion in the right in the beginning. So we have today discussed the properties of determinants in this video. If you like my video, please like, share this video, and do not forget to subscribe to my channel. And if you want to see the verification of these properties, you can look into the next video. Thank you for watching.